What is going on, everybody? Welcome back to the blackboard. We are going to do some examples with diagonalization. In this video, we are going to show or just confirm that the given matrix is diagonalizable by computing the diagonal matrix. So in this one, we already have our matrix S, and so all we really have to do is just multiply them all together, and of course find the inverse of S. And so this is what this video is going to focus on. The next video will focus on actually, finding S and all that stuff. But let's get right into this one. So the first one isn't difficult. Well, they shouldn't be any difficult. But the first one should be fairly simple, mostly because our inverse of S is simply, if you remember long ago, back in the days, that to find the inverse of a 2 by 2 matrix, we will simply just take 1 over -3 times -1, which is 3, minus -4 times -1. Be -4, will be -3 minus -4, be -1. Then you flip the main diagonals, and then you flip the signs on the rest. And so this just simply becomes -1, 1, -4, 3. And that's our inverse. And now to find our diagonal, well, we simply have to do D is equal to SAS, so BS minus 1 AS. And so all we have to do is just really write this down and multiply it all together. Be 1, -1, -4, 3, -11, -3, 36, 10, and then multiply it by -3, -1, -4, -1. All right, cool. And this is just all equal to, gonna carry the first one, we're gonna multiply the last two, so it'll be -11 times -3 is 33, minus 36, and so that'll be -30, not -36, -3, -11 times -4, which is 44, minus 36, that will be 8, and then -3 and 3 would be 9, minus 10, -1, and then 12 minus 10 is 2. Then we multiply with our third matrix, which is our inverse, and we should get -3 plus 4, which would be 1. And then we have 8 minus, or 1 times 8 minus, or plus -4 times 2, which is 8. So 8 minus 8, that'll be 0. Then we have -3 times, or -1 times -3, which is 3. And then 3 times -1, that'll be giving you another 0. And then lastly, -1 times 8 is equal to -8, and 3 times 6 equals 6, so this would be -2. And this will be our final answer. So this one wasn't bad, and as you can see, this tells us that our eigenvalues would be lambda is equal to 1 and lambda is equal to -2. So that's pretty much it with verifying them. All you have to do is really multiply them. I guess the hard part will be the matrix multiplication, and then also finding the inverse if you don't remember how to find them. So now let's continue on with part B, and this gives us a 3 by 3 matrix. Again, we already have our A, we already have our S, so all we have to do is find our inverse of S and then multiply it all together. To find our inverse, if you recall, when it just comes with 3 by 3 and higher, pretty much have to do a super augmented matrix, so 0, 0, 1, in which we write the matrix that we're trying to find the inverse on one side, and then the identity on the other side, and we essentially have to we have to create the identity on the left side, and then whatever answer we have on the right side will be our inverse. What we can do is So we can divide this part by 1/4, or divide it by 4. And then what we can also do is switch this one, the first row and the third row. So that will give us 1, 2, 2, 0, 1, 0, then 0, 1, -3. And so this would be 0, 0, 1, 0, 1/4, 0, 1, 0, 0. And now we are going to get rid of this 1 and this 2. So this would just be 1, 0, 2. This one remains the same. Then this would be 0, 0, -3. This would be 0, 2 minus 1, so it'll be 0 minus 1/2, -1/2. And then this will remain as 1. This will remain unchanged. And then this one will be -1/4, 0. So now what we're going to do is we're going to get rid of this -3. And so that would just be, first two remains the same. 0, 1, 0. This will be 0, 0, 1. And then all of these will follow through. This, however, will be, because we're dividing by -3, this will be -1/3, and this will be 1/12, 0. And so now that's done, we can finally get rid of this last two. And this will leave us with the identity in the left side. The last two rows remains unchanged. So 0, 1/4, 0. And then over here we'll have, because we multiplied it by 2 and subtract it, we'll have 0 minus -2/3. So this should be +2/3. And then right over here we'll have -2/12, which would be -1/6. And this will be -1/2, so 1/2 minus 1/6. That'll be -4/6, which is -2/3. And lastly, we'll just have our 1. And this will be our inverse matrix. It's not very nice because we have fractions, but this is our inverse matrix. So now all we really have to do is just multiply it as usual with the d is equal to SAS. And so it's be 2/3 not 3. -2/3, 1, 0, 1/4, 0, -1/3, 1/12, 0. And then multiply by a, which is -1, 0, 4, 1, 3, -2, and then 0, 0, 5. And then you multiply it by s, 0, 0, 1, 1, 4, 2, -3, 0, 2. And again, we are going to, because it's like matrix multiplication, it usually is from right to left. No, yeah, right to left. And so this will mean that this will be equal to 2/3. So the first matrix remains unchanged. One, 0, 0. And so now we have to multiply these two matrices. And so we're left with, this will be -1, 0, 1, 0, 0. So the first one will be 0. Second one will be -1 and 1, and then 1 and 4, then 0. So this would be 3. And then the last one would be -1 and 1 is, or -1 and -3 is 3. Then we have 0, then 0. And now the second row would be 0, 0, 0. And then again, we'll have 0, 12, 0. And then the last one, which would be 0, 0, 0. And then lastly, we'll have 4, 0, negative 2, 0, and then 5, 1, 4, 1, negative 4 and 2 will be negative 8, plus 4 is negative 4, plus 10 will be 6. And then lastly, we have 4 and 3, which is negative 12, 0, and then 5 and 2 is 10, so this would be negative 2. And so multiply these two, and this will give you our answer. So we have 2/3 and 0, so it'll be 0, and then negative 2/3, 0, and then we have 1 and 5, so this would be 5. And then now we have 2/3 times 3, which would be 2, and then negative 2/3 times 12, which would be negative 8, and then plus 6, so we have negative 8 plus 6, which would be, wait, 8, no, negative 8 plus 6, which is negative 2, plus 2, which would be 0. And then again, for the last one, we have 2/3, which would be 0. Oh, no, 2/3 times 3, which is 2. And then we have negative 2/3 times 0, which is 0. And then 1 and 2, which would be negative 2. That will cancel out and be 0. For the second row, we have 0 and 0. And then 1/4. And 0. And then 5 and 0 would be 0. For the second column will be 0 times 3, which would be 0. 12 times 1/4, which would just be 3. And then 0 and 6, so this would just be 3. For this row, we have 0 and 3. No, 0, yeah. 0 and 3, which is 0. 1/4 and 0, that's 0. And then 0 and negative 2, that will give you 0. So now our last row is negative 1/3 and 0. That will be 0. 1/12 and 0, that will be 0. And then 5 and 0 will also give us 0. Second column would be 1/3. Negative 1/3 times 3, which would be negative 1. And then 12 and 1/12, that would be 1. So that will cancel out to 0. And then we have 0 and 6. We have 0 here. And then lastly, we will have 1/3 negative times 3, which would be negative 1. 1/12 and 0, that would be 0. And then 0 and negative 2. So we'll have negative 1. And this will be our answer. And this, again, this will tell us that our eigenvalues is 5, 3, and negative 1. And that's pretty much it for this video. This wasn't really hard. We just had to verify that this gives us a diagonal matrix. And if you recall in lecture, diagonal matrix gives us a diagonal matrix in which the main diagonal has the eigenvalues. So that will be it for this video, so I'll see you guys in the next one.